Many entrepreneurs and business leaders think that AI means ChatGPT, but ChatGPT and generative AI more broadly are really only one branch of the larger AI tree. And if you're only using generative AI, you're probably missing out on 80% of the value that artificial intelligence can bring to your business. So, in this video, I'm going to explain the three main types of artificial intelligence, as well as when and how to use them. Hi, I'm Joshua Ebner. I'm a 20-year expert in AI, machine learning, and data science. And by the end of this video, you'll understand three of the most important types of AI: generative AI, supervised learning, and unsupervised learning. I'm also going to add one bonus type towards the end that's getting a lot of press and publicity recently. I'll also explain roughly how they work, their strengths and weaknesses, and how you can use them, at least at a high level, to solve various business problems. Okay, let's get started. The first type of AI that I want to talk about is generative AI. Now, generative AI is the type of AI that I think everyone's kind of familiar with right now. It includes ChatGPT and Sora, different large language models that generate text. This also includes models that generate images and video. And at a very high level, what generative AI, as the name implies, generative AI generates outputs. And more specifically, in the case of large language models, they generate text based outputs. Now, this has a lot of uses. Let's talk about some strengths and also some weaknesses. In terms of strengths, they're really good at working with text based input. So that includes documents, written text, things that you write, like prompts, etc. And in fact, that's largely the interface for large language models, as well as other types of generative AI like image generators. It's text based input. They're also really good at specific tasks. So, for example, large language models, they're obviously really good at generating text outputs. They're also good at summarizing documents, summarizing text, and generally operating as a sort of advisor. We typically call this a question answer task. But in terms of weaknesses, generative AI can often make mistakes. This is most commonly seen with hallucination in LLMs, where they very confidently tell you something that is just factually inaccurate. Now, large language models are getting better, but I suspect that this is going to be a difficult problem to solve because of the nature of how they operate. They also often forget information, and they don't inherently know everything that you need it to know. So you often need to do a lot of what we would call context engineering. That's not strictly prompting, although prompt engineering is a part of it, but context engineering is broader. And that means giving it access to documents and databases and systems. Many people are not doing this right now. They're simply typing in prompts into the prompt window. But in reality, if you want to get an LLM to work really well, you need to give it access to documents and databases, vector databases. And you often then, on top of that, need to engineer very good prompts so it has enough context to give you a really good answer. This can help mitigate the problem of hallucination, but it introduces some new complexity because you need to manage exactly what information to give it. There is such a thing as giving it too much information. So this problem of prompt engineering, but more broadly, context engineering, I think is going to become very important for fixing some of the inherent weaknesses in LLMs and generative AI. In terms of uses, we see things like summarizing documents, summarizing text, generating text, etc. So you can use it for things like generating marketing copy, drafting a contract, although I will say that that can be a little bit dangerous. You should have a lawyer in your business look at drafted contracts, but it can help with that. I have used it myself to actually look at proposals and contracts and just try and figure out what's going on. You can use large language models for sentiment analysis. This can be very useful for marketing and customer research, as well as customer satisfaction optimization. Although there are different model types aside from LLMs that are actually better at sentiment analysis. We call these encoder only models. They're related to large language models. I'll set that aside and maybe talk about it in a different video another time. But they can do some sentiment analysis. They're also, as many people have learned, they're pretty good at writing code. Having said that, you often need lots of constraint. You often need to give it lots of context, as I said earlier. So, context engineering. And then you also often need to verify the outputs, whether you're generating documents, generating code, or something else. So, I think that this sort of process of context engineering and validation on the back end, this is going to become increasingly important as people learn how to integrate LLMs into their business. Next, let's talk about the second major type of AI, predictive models. In the industry, we actually have a word for this. We call these types of models supervised learning models. For the most part, when we build predictive systems, we're usually using supervised learning. Supervised learning essentially takes an input data set and we train a model to produce an output. Now, you might be saying, sure, large language models produce outputs, right? It's a little bit different. LLMs produce text, so lots of text. We have other types of generative systems that produce video and things like that. Supervised learning systems are a little more constrained. We typically divide them into two different types. There are two main types of supervised learning. There are classification systems that produce categorical outputs. So, yes or no, churn or not churn in the case of a churn model, good or bad. They're typically just producing categorical outputs, and those categories are predetermined. We know what they are in advance. The second type of supervised learning is regression, and in regression, we're predicting numbers. So you can kind of make some guesses about some uses. If you're predicting sales numbers, you're probably going to use a regression system. If you're predicting churn or upsell propensity, you're going to use a classification system. These are classic systems. This is, in fact, a classic type of AI. They've been using these systems in industry for decades. So, this is a really important type of AI. And if you're overlooking it in favor of ChatGPT, you're missing out. So, very quickly, in terms of strengths and weaknesses, the strengths are that they are much more accurate and precise at making predictions. So, I will say that you can use things like LLMs to make certain types of predictions. They're generally not that accurate, large language models. So if you're making predictions, you're generally going to use supervised learning. And if you do this right, you can optimize all sorts of different parts of your business. As I just sort of suggested, FANG, big banks, they've largely won on the basis of supervised learning, at least in part, over the last couple of decades. In terms of weaknesses, though, they often require large amounts of data and in particular formats. As I said earlier, they typically require lots of structured data. You often also need to clean that data to get it into the right structure. We typically take a raw data set out of a database or spreadsheets, other sources, and you often have to do a lot of processing on that data in order to get it to work properly. So, this can be a fairly big challenge. They also, over time, even after you build or train a good model, they can often drift or change over time. That happens with many types of machine learning, including some types of LLM systems, but it is a particular problem and a well understood problem in supervised learning. Again, we call this model drift. And finally, they're kind of constrained in terms of the outputs. So, regression systems only output numbers, classifiers only output categories, but they do have their uses. As I've already suggested, many businesses have been built and optimized on the basis of supervised learning in large part. So, for example, churn is a big one. So, for SaaS companies or any sort of company where there's recurring payments, like monthly payments, retainers, things like that, you can build churn models. And depending on how you build them, you can often use them for analytical purposes to figure out what the drivers are of churn. And then you can use them for predictive purposes to predict who is going to churn. And if you can predict who's going to churn, then you can go and talk to those people and try to intervene in some way. Just say, hey, how's it going? Are you having any problems, etc. So churn is a really big use for classification systems. There's also things like upsell propensity models where, let's say you have different tiers of your service. This is very common in SaaS. Let's say you have a basic plan and a premium plan, and you're trying to predict in a upsell propensity model who's going to upgrade or who's likely to be ready to upgrade. If you can predict that, you can go talk to those people and try to upsell them. So, those are just two examples of uses of classification systems. For regression systems, you can do things like, as I suggested, try to predict your sales numbers. And if you can make these predictions, you can try and optimize your business and also make some strategic plans. So, supervised learning is very, very important if you know how to use it and when to use it. Okay, moving on. The third type of AI that I want to tell you about is unsupervised learning. So, in the previous section with supervised learning, you have an input data set that's already pre prepared and often fairly structured, and then you're predicting some sort of output. So, there's an input and an output. Unsupervised learning, which I'm talking about here, is a little bit different. We typically have an input data set that's fairly unstructured, although we often need to have it cleaned up and prepared in certain ways, but there's no output. So you might be asking yourself, how can you possibly use something if there's no output? Well, with unsupervised learning, what it's doing is it's finding structure in data. So we give it an input data set, and then it finds structure and patterns that were previously unknown or unseen. This can be very useful for certain types of strategy. In just a minute, I'll give you some examples of how we use this, very commonly used in marketing and product. In terms of strengths, like I said, it's good for finding patterns which we can use for strategic purposes if applied correctly. In terms of weaknesses, though, it's often much less precise. Typically, it's very exploratory in nature, and it's often a little bit more of an art than it is strictly a science. There is some science to it, but often you need someone that really knows how to use these techniques. There's a lot of trial and error and a lot of intuition that comes from having a good AI expert or data scientist that knows how to use the technique properly. So let's very briefly talk about some applications. Unsupervised learning is used very commonly for market segmentation and then segmentation for the purposes of product. And we use this often for designing or making great products, making products that people love, and then for go to market. So for marketing, what we typically do is we'll take a customer or prospect base that might be very large, and then we'll try and find subsegments. So the specific algorithm or technique that we use for this is typically clustering. K-means clustering in particular, although there's a variety of clustering techniques that we can use. K-means is very common. I'll set that aside, maybe talk about it in a separate video on clustering all by itself. But when we use segmentation for marketing, we take a very big customer base and then we find the subsegments. So we have the big customer base, and then we say we have this subsegment over here, and then a different one, and then maybe a third one, and there can be multiple different segments. Then, after we identify the segments using an unsupervised learning technique like clustering, then we analyze those segments, sometimes with data analytics, often with customer research, surveys, interviews, other techniques, and you can figure out what those different segments, what they like, what they want, what they're frustrated about, what their values are. You often learn things about their demographics, etc. And that can help you build a marketing strategy. If you know what they want, you can figure out how to give them exactly what they want, how to communicate with them, what the best messages are that will resonate with those people, and so on. Similarly, we can use basically the same technique, clustering for purposes of developing a product. This is very commonly done more in the startup phase, but many large enterprises do this, like Facebook and Google. They do lots of segmentation for product. I know a guy that used to work at Google doing just that. So essentially, what they do is they take a full customer base and then divide it into segments, figure out what the different segments like in terms of product, and you can build a product with very specific features that satisfy those different segments. You can also decide to serve only maybe one or two segments out of many segments. And this helps you build a product strategy, a marketing strategy, and an overall business strategy. If you're focusing on the wealthiest and maybe most profitable segments, that can help you drive revenue and profit in your own business. So this is very closely tied to business strategy and product and marketing strategy, one level beneath that. So again, to sum up, this third type, unsupervised learning, very good for finding patterns in data, which in turn can help you define a strategy for different parts of your business. Okay, finally, let's talk about one bonus type. And this is a type that's been really in the news and on social media in the last 6 or 8 months. That's AI agents. AI agents are kind of related to large language models in the sense that they incorporate a large language model, but they're different enough that I would kind of talk about them in a separate category. An AI agent uses a large language model sort of at the center as a reasoning engine or planning engine. But then we give it access to other tools and systems that give it access to things like data and information, databases, vector databases, document stores. You can give a AI agent access to other software via APIs and other tools and so on. So you end up having a large language model and various information sources and tools, and that at least theoretically enables an AI agent to take actions somewhat independently, although there's often human in the loop architectures that will incorporate human oversight. Setting that aside, the dream of an AI agent is that it does work on behalf of a human and can sort of offload work. Now, in terms of strengths, ideally, they'll act like artificial employees and actually operate inside of your business, making individuals more productive and maybe replacing, for better or worse, replacing certain types of workers. That's kind of like the ideal case. The weakness here is that it's still very early, and a lot of people are struggling to get AI agents to work properly. Now, I think that many people are kind of trying to hack these things together and they kind of don't know what they're doing. AI agents, for example, they often need to be trained to do serious work. They, for example, need to be trained to use specific tools. If you just give it access to a piece of software, it's very frequently going to fail unless you give it training examples for how to do that. So, we're probably going to need to actually retrain human beings to some extent to teach human beings how to train these AI agents properly so that the AI agents do real work. So there's all sorts of problems with this. There's also things like giving it access to databases and data stores. There's questions around privacy and data access. What data sets can you give it access to? Where should you draw limitations? There's problems around architecture and involving humans, like I said earlier, human in the loop. And then there's questions of measurement, performance benchmarks, and even further, once you build a system, like many other types of AI and machine learning, but this is maybe particularly true going forward for agents. Once you build the system, there's often a sort of drift. In classic machine learning, we call this model drift. And this happens with AI agents as well. You might train it to do something, it works really well, but something changes about the inputs or maybe changes about the nature of the task. And the agent kind of drifts. Its performance degrades over time. So even if you can construct the perfect agent today, let's say in 6 to 8 months, the performance might degrade and you have to retrain it all over again. So there's all sorts of problems around what we would call proper AI engineering, getting the thing to perform right, measuring its performance, monitoring over time, access permissions, all of that stuff. So people that are just trying to kind of like hack this stuff together in a weekend, they're not really thinking this through. This is really going to require serious AI engineering chops to work well while also mitigating risk. In an ideal world, though, going forward, in terms of examples, I think that we could potentially see AI agents doing things like administrative tasks, certainly simpler, more repetitive administrative tasks. This will help offload work from employees, which will in turn enable those employees to focus on higher value tasks. So, AI agents, this is, I think, going to be very powerful going forward for building teams, although we're going to have to rethink how we engineer internal workflows, and then even how we engineer our organizations once we have AI agents ready to do work and work alongside human beings. Okay, so those are the three major types of AI that I want you to know about, plus one bonus. So that's generative AI, supervised learning, unsupervised learning, and the bonus being AI agents. Ultimately, what I want you to walk away with is that AI isn't just one thing. Generative AI does not do all of the things and solve all of the problems. Generative AI is really one tool in a larger AI and data science toolkit. You need to understand what the different techniques are, what they do, what they're good at, their strengths and their weaknesses. And then you need to understand how to use those tools and techniques in your business to solve particular problems. What do you think? Have you tried to use LLMs and generative AI for things that they maybe weren't that good at? Have you gotten frustrated with LLMs? Have you used or are you interested in using some of these other types of AI like supervised learning, predictive models? I want to hear from you. Leave a comment.